Okay, so the next thing we're going to talk about here is the unit circle. This is a really important thing in trigonometry, and we'll use this the rest of the year. You will fill this out, so please do so nice and neatly so that when you reference this later, it's easy to find what you need. Okay, so this is called the unit circle because the radius of this circle is 1 unit. Okay, so I actually kind of want to talk about this. We're going to maybe talk a little bit about what sine, cosine, and tangent mean in the unit circle. So as I just mentioned, this is my radius. This is r. Now in the unit circle, it's 1, okay? But that's my radius. And just like with anything in a coordinate plane, the side-to-side distance there is x, and the up and down distance here would be y. So when I think of things like, well, let's put theta right here. That's my theta. Let's say I said sine of theta. What would you say that is? Well, sine is opposite, so in this case that would be y, over the hypotenuse r, right? But we know that that's 1, so this is really just y. So sine of theta is y over r, but in the unit circle, it's y over 1 or just y. So I'm actually going to write that in here, and you should too. Okay, so cool. Now let's say we look at cosine. I'm going to erase this here. Okay, so cosine, maybe I'll just write it in here. Cosine of theta is adjacent, which adjacent would be x over r. And because r is really 1, this is just going to end up being x. Okay, let's put that in here. Okay, now tangent is a little simpler. Tangent, let's see, is opposite over adjacent, so y over x, and there's no r in here, so that's gonna stay y over x. Okay. Now, so that's important. Sine is y, cosine is x, and tangent is y over x in the unit circle. Okay, and you saw y. All right, now we're going to start filling all this out. And in order to do so, let's just kind of talk about some points that we already know. So first of all, we already know this distance right here is 1 unit, right? So what would be the coordinates at this spot right here? Well, it would be 1, 0. And we'll just stick with that, 1, 0. Okay, and so how about up here at 90 degrees? If that radius is 1 unit, then this would be 0, 1. Okay, and now let's go to 180. So this would be to the negative direction, so this would be negative 1, 0. And now let's do 270. If it was 1 unit down, right, that would be, this would be 0, negative 1. Okay, so there I have those ones right there. So now what we're going to talk about, let's look at these 45-degree increments. So how do we find what the value of those are? And let's take a look. You might remember from geometry a 45, 45, 90 triangle. So these have a special relationship. If you remember, these two sides are going to be the same, okay? And then the hypotenuse, if you recall, is x, whatever x is, times the square root of 2. Okay, so, well, let's figure this out. Now, in the unit circle, we just said the radius is 1. Well, the radius is right here, so let's set that equal to 1 and then solve for x. So now if I say, let's see, 1 equals x divided by square root of 2, to get x by itself, I would need to divide by the square root of 2. So really x is equal to 1 over square root of 2. Well, problem with that is that has a square root of 2 in the denominator. I can't have a square root in the denominator, so I'm going to fix that. So this would end up being square root of 2 over 2. That's my x. So what does this mean? Well, it means that this is x, right? And so is this. So these are both square root of 2 over 2. Square root of 2 over 2. And this would be then, the radius would be then 1. Okay, so this is really just 1 now. Okay, now, if I use this triangle that we just made, and I think about having a triangle right here, that's 45 degrees, right? We just said that this distance is square root of 2 over 2, and this distance is square root of 2 over 2. Okay, so what are the coordinates of this point right here? Well, it would be x is square root of 2 over 2. Right? That's this number right here. And y is this number right here, which is also square root of 2 over 2. So I'm going to write that in there too. Okay, so now we've got that. Now this actually works for all of these, right? All 45 degree increments. So I can actually do this. They're going to be the same. We're just going to be difference with positives and negatives. So those are my 45 degree increments. And so I'm going to go over to 135. Well, this is in quadrant 2, and x is negative, and y is positive, right? This distance is negative, this is positive. So that means x is negative. This would be negative square root of 2 over 2. And y would be positive. All x values in quadrant 2 are negative, right? So then if we go down to quadrant 3, right, x is negative, and so is y. They're both negative. So this would be negative square root of 2 over 2, negative square root of 2 over 2. And then here in this quadrant, we have x is positive, y is negative. So let's fill this out. This would be square root of 2 over 2 and negative square root of 2 over 2. Okay, so now, one of my 2's disappeared here. Okay, so now we've got some of this filled out. And then let's talk about maybe these 30, 60, 30 and 60 degree increments. So let's start with a 60 degrees and kind of work our way around. So I want to look at a 30, 60, 90 triangle, right? So if you remember these as well, they have a certain relationship. And that was that this side is x. In the hypotenuse, this is kind of weird. The hypotenuse was 2x, and then this other leg was x root 3. So it's kind of a weird relationship. Now, for our purposes, in the unit circle, we know that this is 1, okay? So now if I want to know what x is, I would divide by 2. So that means if that was 1, this is half of that. So this is 1/2, right? If I divided by 2 on both sides there. Now, that means if x is a half, then this would be 1/2 root 3 Well, we would generally write that in a different way. We usually write this as square root of 3 over 2. This is more typical. So that's this distance here, and you've got a half, and we got 1. So now if I come up here to my unit circle, 60 degrees, let's see, I got my triangle here. This is square root of 3 over 2. This is a half, and this is 1. Now, what's x? Well, x is a half. So let's maybe go back to this is 1/2. Okay, and y is square root of 3 over 2. That's the distance up. Okay, so now using this as my template, now I can fill out all these other ones. Okay, so I'm going to do these other 60 degree ones. So 120 is going to be the same as 60, just x is going to be negative. So I'm going to have negative 1/2, and then square root of 3 over 2. Notice how those are the same, just different signs, right? So now if I go down here, I'm going to have in quadrant 3, they're both going to be negative. So I'm going to reflect across. So down to 120, this is going to be 240 is the one I'm going to look at. So this would be negative 1/2, negative square root of 3 over 2. And then 240 to 300 here is my next one. This will be, x is going to be positive here and negative. I should zoom in a little bit. Square root of 3 over 2. Okay, so now that we have those, cool. So now 30 degrees, we need to do the other ones that are missing, and then we've got our unit circle kind of filled out for the most part. Now 30 degrees, if I tip it on its side so it's like this, right? What is this going to look like? Well, really, this short leg is half is right here. The hypotenuse here is 1. You know that. And then this is square root of 3 over 2. So now, if I think about that, right? This is a half, and this is square root of 3 over 2. Okay, so now that means my x value this time is square root of 3 over 2. And this is a half. Okay, so now I want to do that same thing for 150, except I want to make x negative. Okay, and then we're going to do 210, where they'll both be negative. Okay, and then here 330 degrees, x is positive in this quadrant, and y is negative. Okay, so now I have my unit circle partially completed. Okay, and now what we're going to do is we're going to actually fill out a little bit more of this, and this is a little weird. So what we have is something called radians in here. These are radians, and we're going to fill those out here in a second. So we're going to take a few minutes to do that. Okay, so radians are measured in terms of pi, and they're used based on the circumference of a circle. So you know the circumference of a circle is pi times diameter. Okay, now the circumference of a circle, in this case the diameter, right, is 1. That's the radius, so the diameter is actually 2, excuse me. So we should have, okay, so circumference is 2 pi. So that would be the distance all the way around is 2 pi. Okay, so what we do is measure angles in terms of the distance around. So kind of similar to degrees, these are really similar. So if I go all the way around this circle, right, 360 degrees, this is 2 pi radians. I'm going to write this in a different color maybe. So that would be all the way around the circle. Now it's 0 if you don't go anywhere. But if I go all the way around, that would be 2 pi. So that's 2 pi and 360 are the same. So if I go halfway around, so just to here, as you might guess, this is half of 2 pi, which would be 1 pi. Okay, so now let's try to think about this and go to 90 degrees so you can get some of these easier ones. So if this is pi right here, 90 degrees is half of that. So this is going to be half pi. We usually write this as pi over 2. Same as 1/2, right? This is really a 1. So you'll get used to that notation, but that's pi over 2. So then, what is 270 degrees down here? Well, this is 1 pi. This is 2, or 1 pi over 2 would be right here. And then this would be 2 pi over 2, also known as 1 pi, right? So that means this would be 3 pi over 2. Okay, and then this would be 4 pi over 2. 4 over 2 is 2, so we get 2 pi. So that makes sense. Kind of weird, I know. All right, so let's kind of go with the 45 now. 45 degrees. If 90 degrees is a half pi, what is 45? Well, half of a half is a fourth. So this is 1/4 pi, also known as pi over 4. Okay, so this is 1 pi over 4, 2 pi over 4, reduced to a half. So that means this is 3 pi over 4. This would be 4 pi over 4, or 1 pi, meaning this would be 5 pi over 4. 270 would be 6 pi over 4, reduced to 3 over 2, meaning this would be 7 pi over 4. You may want to put that there. I might make that a little bit better, 7. Okay, and then you get to all the way around, it would be 8 pi over 4 or 2 pi, right? Okay, now let's do, I don't know, let's try 60 degrees. Let's see how good we are. So if this is a little tricky. If this is 1 pi, that's 80 degrees. This is a third of that. It's 60 degrees, right? So this should be 1/3 pi, also known as pi over 3. So then 120 would be 2 pi over 3. And 180 would be 3 pi over 3, which is 1. Okay, so then we're going to go to 240, and that would be 4 pi over 3. Okay, and then another 60 degrees, and that would give me 5 pi over 3, which would be right here. And then 6 pi over 3 would be back to here, 2 pi. Okay, now we just have our 30 degree increments. Okay, so if 60 degrees is a third pi, then half of that would be half of 60 is 30, so half of a third is a sixth. So this is 1/6, or pi over 6. So then 60 is 2 pi over 6, or a third. 90 is 3 pi over 6, which is a half. And we can just kind of keep going around, right? You get 3 pi over 6, 4 pi over 6, reduced 5 pi over 6, then that makes this. Okay, this would be 6 pi over 6. So this is 7 pi over 6. And then 8 pi over 6 reduced, right? 4/3 right here. 9 pi over 6 reduced, 3/2. 10 pi over 6 be 5/3. And then that means this is 11 pi over 6. And then 12 pi over 6 would be 360. And we have, which is reduced to 2 pi. And now we have our unit circle complete. Sine is y in the unit circle, cosine is x, and tangent is y over x. And if you want to fill this out, you can. You just know what is sine. Sine is y. So you can say, well, y in quadrant 1 is positive. Y in quadrant 2 is still positive. In quadrant 3, y is negative. And quadrant 4, it's also negative. So cosine is x. Well, x in quadrant 1 is positive. In quadrant 2, it's negative. In quadrant 3, it's negative. In quadrant 4, it's positive. Tangent, this would be y over x, right? So in quadrant 1, you're doing y over x. It's a positive divided by a positive, which would always be a positive. And in quadrant 2, it's y is positive, x is negative. So this is going to be negative when you divide them. Okay. In quadrant 3, they're both negative. So divide a negative divided by a negative, you get a positive. Quadrant 4, x is positive, y is negative. So this would be negative. If that helps, otherwise just do your normal thing and that'll work. So that is the unit circle completely filled out. Make sure yours is filled out. Hope that makes some sense.